Hi, so today we're going to go ahead and go over the fourth chapter of Designing Social Inquiry. We're going to actually look at what are known as indeterminate research designs and some sort of impediments that make research designs indeterminate, especially with a focus on qualitative research. So the first thing to know about indeterminate research designs is that IRDs are simply unable to examine causal hypotheses, and that's because of a number of factors. The first being that indeterminate research designs might have a circumstance where there are more inferences that you're attempting to draw than observations that you have. This is sort of known as the K is greater than N problem, N being the number of cases and K being the number of observations you wish to make, or number of inferences you wish to make from those from your cases or from your N. So in this circumstance, the research design is indeterminate because we don't have enough data to actually look at alternative explanations. And the other circumstance is that if two or more of your explanatory variables, that is your independent variables, are perfectly correlated with each other. And in statistics lexicon, we call that as multicollinearity. And we're going to look at both of these in some detail in the following slides. So first, looking at the K greater than N problem, this is a circumstance in which you have more possible explanations which you're wishing to test and explanations which you're wishing to outrule than you actually have observations. And in this circumstance where you have more competing explanations than you actually have observations, you're unable to rule out competing sort of hypotheses or competing explanations. The really easy way to get around this, easy, and I say easy sort of with a shrug, when we're studying, when we're doing small N studies, this sometimes isn't possible. But if we add more cases to the study, then we can test more possible explanations. So by giving a study more cases or granting more cases to a study, increasing our N, then we can assess those implications that we want to draw, those inferences that we want to make. And we can do that by adding more cases so that the N becomes greater than the K. The other example of a thing that will lead to indeterminate research designs are multicollinearity. Now, in statistics, this has they have different definitions when we're looking at quantitative research versus qualitative research. In quantitative research and statistical research, multicollinearity is when two independent variables are strongly correlated. So multicollinearity simply discusses, it's a theoretical concept, but it's also a statistical concept. But in the theoretical concept, it's when two variables are so interrelated, so strongly correlated that you cannot assess their independent effects on some sort of outcome. So let me give you an example of what that looks like. We know that education is a pretty significant predictor of vote choice. We also know that income is a pretty significant predictor of vote choice. But education and income are naturally correlated and usually fairly strongly correlated. And so when we put all of those in a model, oftentimes without other controls or other sort of design elements, it's difficult to extrapolate the independent effect of education and income on vote choice, because the two are sort of absorbing each other's variance, and therefore their independent effect is very difficult to determine in terms of that modeling situation. In qualitative research, it's a bit different. In qualitative research, when we say multicollinearity exists, what we mean is that one of your independent variables perfectly predicts another independent variable. In that circumstance, when both of your independent variables are exactly the same all the time, let's think of it in a very easy sense, dichotomous variable. So that is a variable that can take two values, 0 and 1. Let's say every time in your research, every time you have a 0 on variable A, you have a 1 on variable B, and every time you have a 1 on variable A, you have a 0 on variable B. Because one independent variable perfectly predicts another, if you're trying to examine outcome C, you actually cannot assess the independent effects of A on C or B on C, because A and B perfectly predict each other. And therefore, any sort of independent effect on the outcome which you would like to draw some causal inference to, that is C, is simply impossible to do because of the setup of your data. Now, there are certain ways to get around this, and in quantitative research, we would tout randomness, and I'm going to explain why that is here. So in these large N studies, randomness, so drawing cases at random, assures that the selection process of getting cases is entirely unrelated to the value of the variables within them. So think of this in terms of polling. If we poll randomly, that is 100% randomness in how we draw a public opinion poll, then we know that our selection rule has no bearing on the values which we're attempting to measure within that sample. That they can't be related because the design selected these individuals by random, and that randomness sort of erases any relationship between the way by which we drew the sample and the actual value of the variables that we're examining within that test. But in small n research, that randomness may be entirely undesirable. Because if we select cases at random, we can actually introduce a selection bias mechanism. If we select randomly from a population for a small n study, we might not actually get the variation we need to assess outcomes. So that circumstance I explained on the last slide, in which all the zeros predicted, all the zeros in variable A were ones in variable B, and all the ones in variable A were zeros in variable B. Well, if you've got 6 cases and you chose them randomly from a selection possibility of, let's say, 20, well, your selection mechanism, that is random choice, actually introduced selection bias, which should be a bit ironic. In large N studies, we use that randomness to eliminate any selection bias. So the tool of randomness, which is exceedingly used in quantitative studies, might itself introduce biases into small n qualitative research. So in the quantitative research, that large N research, we never want a selection rule, ever, that chooses cases based on the values of the outcome variable, that is the dependent variable, because our selection rule would then be affecting our outcome. And that would make us attempting to assign causality or any sort of causal inference very difficult. In qualitative research, however, choosing on the dependent variable is sometimes necessary and sometimes preferred. Because by choosing on the dependent variable, it gets us a quality that we need, and that quality is variation. We're only able to draw causal inference in any sort of study if we have variation upon the dependent variable. So while in large N research, we don't want to sort of, what we can say in parlance as cook the books, by using a selection rule that chooses cases based on the value of the dependent variable. In qualitative research, sometimes we absolutely need to do that so that we have variation in the dependent variable. And so this randomness, which stops selection bias in large N research, can actually cause it in small n qualitative research. So we sometimes use a rule to select cases in small n research on the dependent variable to ensure that we have variation. There's another way to get around this sort of selection bias that is much more permissible in both large N research and small n research, because we usually get to the same goal. And that is choosing based on our explanatory or independent variables. By choosing on your independent variables, you aren't conditioning the outcome. And so in large N research, what that means that you're not affecting the quantity of which you're attempting to study. That's absolutely true in small N research as well. If you're choosing on your independent variables, then you're not affecting the outcome. But because there's a smaller number of cases, sometimes choosing on independent variables is not as easy as choosing on dependent variables in small N research. So while it's a tool that's available, it isn't a panacea. It doesn't fix everything in small N research. So what can we do to sort of get around this when we have to do intentional selection in small N research? Well, first, you can try to select on the explanatory variable, which make sure that your outcomes, which you're attempting to observe, actually vary. Or you can make sure that you choose cases based on values of the dependent variable and selecting on a range of the dependent variable. It is making sure that the dependent variable is not just a 0 or 1, not just dichotomous, but has a large range. So you can select on your independent variables, those variables which you think will predict your outcomes, or you can select on the outcome variable, which is to say it's best to do so in a range and not just a dichotomous sort of thing. But as a warning, do not choose cases based upon your explanatory variables and also your dependent variables. So you shouldn't choose cases based on your independent variables and dependent variables. And the reason for that should be sort of intuitive. If you're assuming via your hypothesis that X leads to Y, and then you choose cases based upon X and Y, you are simply basically demonstrating that your hypothesis is true. But that's because of case selection, not because of research design and what's going on in the real world. So while you can choose in qualitative research, you can choose on explanatory variables, that is your independent variables, or you can choose on dependent variables to make sure you get variation in the dependent variable. Absolutely, we can't choose on both at the same time because in essence, we're going to be creating the outcome we wish to see within the population.